sedimentary petrography, and as you can see, we are doing the sedimentary rocks. And yesterday we started the clastic sedimentary rocks, and in clastic sedimentary rocks, we have started with the major type of sedimentary rock, that is the sandstone. And we are trying to differentiate with different types of sandstones, and in that we are trying to study grain types. And the first grain that we are studying, or the first mineral that we are studying, is the quartz. and and you can see that the quartz grain that is in the EPL is seems to be uh, colorless, or it doesn't have any internal structure that can help you to identify the mineral. However, in the cross polarized, you can clearly see that the quartz grains has a number of patches, and this is called the extinction, and it is a special type of extinction in which half of the mineral is extinct and half of the mineral is still present in its present form. And you can say that this part is still have some light, and all of the light is gone here. And once you rotate the stage, then maybe this area becomes darker and this area becomes lighter. We call this process as undulose extinction. And endless extinction is also helpful in identifying different type of quartz. We have seen some quartz yesterday. As you guys remember, we have seen this polycrystalline quartz. Similarly, this quartz could be possibly made up of various grains, and these grains are formed in a condition like maybe in igneous rocks, or maybe from the metamorphic rocks. Based on the undulous extinction, sometime we can understand the like if there are so many grains with the undulous extinction, then we can say that the source area for this particular rock was igneous or metamorphic. Okay. And sometimes the quartz minerals, they have some inclusions, and they have some lines or striations that indicate that they are formed in a very typical type of environment. Such type of milky colored or light colored type of quartz grains with some striations or some lines are thought to be formed in hydrothermal conditions. And they indicate that most of the grain, like the quartz, was derived from an area where there was hydrothermal activity. तो अगर इस तरह का quartz आपको नजर आएगा जिसके अंदर you have lines on it, and it appears to be milky, and it doesn't have other quartz characteristics, then maybe this quartz is basically derived from a hydrothermal solution area, or hydrothermal vein, or hydrothermal deposit. Then comes the next important mineral, that are the feldspars. Feldspars, always remember that they are the second most important constituent of most of the sandstones and conglomerates. And feldspars, as you know, they are further divided into various types. We have alkali feldspar, we have plagioclase feldspar, and some of these feldspars, they are resistant to weathering, and some of them, they are less resistant to weathering. Like for example, alkali feldspars are more common, as they are resistant to weathering as compared to the plagioclase feldspar, or the calcitic plagioclase feldspar. And sometimes the chemical weathering, they also impart different type of clays on these feldspars, and we can also identify based on that particular alterations. And if in that particular area mechanical weathering is more prevalent than the chemical weathering, then chances are there that the grains that you will have will be feldspar rather than the quartz. But if your area in which your rocks are formed have more chemical weathering, then the chances are there that quartz will be more dominant and feldspar will be less dominant. Similarly, it also depends on the transportation of your area. If your area, that is the depositional site, is located very far from the source, then maybe the chances are there that all the feldspar that was coming to that area has already been weathered out or has already been uh, gone in the process of transportation. Alteration, yes, alterations are very common in most of these feldspars, and that give them certain appearance that can be helpful for identification. And here we can see a mineral that have a very distinct shape. However, we cannot see the internal fabric. Once we turn into the cross polarized view, you can see the twinning, that is the evident, and that is particularly the style of twinning that we have in the uh, feldspar. So this is the twinning style that we have normally in the feldspar. It is a sample from a conglomerate. Then we have another example of feldspar. This is a different type of feldspar, and you can see that the hash type appearance or the microcline cleavage in this cross-hatched twinning. So you can see that very distinct. Maybe you guys remember from your class of igneous petrology that we had some minerals there in which the twinning was there, and we call those minerals as microcline. Microcline also sometimes they can have bigger crystals in sandstones, and they have also you can find other plagioclase minerals in this sample, like the twinned minerals, and also few of the quartz minerals with overgrowth cements. So these minerals are carbon, and sometimes these have appearance of the perthite texture that we will see shortly in the next scene sections. Most of the stuff that we have already read in the igneous petrology can also be helpful for understanding your thin sections in the sedimentary part. And just like in the next thin sections, we will see few of the perthitic texture in which two feldspars they grow with each other. And as you can see that we have the lamina of sodium rich feldspar in potassium rich feldspar. So it was a potassium rich feldspar, and the lamina, the light color mineral that you see, is actually the sodic rich feldspar. And this indicates a perthite type of texture, and that indicates that you can based on the criteria can identify these type of feldspars in the thin section. Similarly, in other parts of the same thin section, you can see some quartz minerals, quartz grains, the next dominant mineral in this, and you can have some quartz with the cloudy appearance. Yes, in this thin section, you can also see that we have quartz grains and some of the microcline type of cleavage, and they also represent some sort of 15 and 16 grains of orthoclase and quartz. The feldspar can be identified in the PPL view by its cloudy appearance due to alteration, and feldspar can easily be identified because of its cloudy appearance. Let's go to the next. Then we have the rock fragments. Rock fragments, as we have said, the next important part of the sedimentary sedimentary petrography, and here we can see that we have distinct pieces of rocks. Normally in sandstone, there are three main constituents: quartz, feldspar, and rock fragment. So we have already seen few of the quartz minerals and few of the feldspar minerals. Now the third important part is rock fragments. And in rock fragments, you can clearly see there are few minerals that are present, and these pieces are actually derived directly from the rock, and these pieces indicate that in that area the physical weathering process was very fast, and as a result of that physical process we have the presence of these rock fragments. Remember, understanding the type of rock fragments sometimes can help you in understanding the provenance area from where the sediments are being brought to this area. Like for example, if you have some special type of rock fragment that is incorporated into your rock. These pieces, because you cannot see the grain size and the details even in the thin section, maybe they are from the shale, or maybe they are from the slate material that was already present. And you can see that overall the appearance of this thin section is quite dirty, and you can see even the small rock fragments that are scattered here and there in the thin section. This is another example of how we can have a piece of already existing rock. Remember, already existing rocks can be sedimentary, igneous, metamorphic, and all these rocks can supply sediments, and they can also supply the whole rock pieces to the newly formed sediments or sedimentary rocks. Similarly, we can also have the sediments from chert. Chert is, as you guys know, is also a sedimentary rock that is like very fine grained sedimentary rock. And sometimes we have the composite grains of quartz, as we can see in the next thin section. In the plain polarized light, you can see that there is a big quartz mineral, but you cannot understand the details. And here you can see clearly the the thin section in which you can see quartz minerals, and these quartz minerals, you can see there are some small mica flakes that are bordering these quartz minerals, and these quartz grains, they are bordered by the quartz, and they are bordered by the micas. Now, this type of texture is very common in what we call the schist or schistose texture, that is common in the quartz mica schist. Then there are chances that this grain or this rock type could have been formed from an area where the systems, or where the conditions were having the provenance was actually a metamorphic provenance, and from where the sediments were derived. Then we have another example, and in this example you can again see a rock, and then the bigger rock fragment, and in that rock fragment you can see that it is constituted by a piece of another rock. Let's see what this piece has to do. And yes, so maybe this is a piece from the already existing sedimentary rock, and you can see that the small quartz grains that are present here are already cemented by a very fine grain clay, and these fine grain clays are present here as a cement, and they were bonding this sandstone. So maybe possibilities that there was sandstone deposited at some place, and then it was uplifted, and then the sediments were derived from there to a new basin, and where it was deposited. So maybe these rock types, the rock fragment types, they can tell you the information about the area from where they can be derived. The next thin section we have, I think probably the last for today's discussion, is having some needle type of this rock fragment has some needle type of appearance, and these type of rocks, with reference to what we have studied in the previous section of the class on igneous petrology, you guys remember that dark color minerals are mostly the ferromagnesium minerals, and there is one light color mineral that is present on the right side of the thin section. And most of these dark color minerals are rich in ferromagnesium, and are as a result of the volcanism. And then once we have volcanism, and then the fragments of that volcano or the sediments from the volcano may be deposited in a nearby basin, and then as those sediments were deposited, we have the rock fragments of volcanic origin. And you can also see that we have some ground mass, very fine grained ground mass, and we have the alteration of some of these volcanic rocks. Remember, volcanic igneous rocks are very easy to weather, and mostly if you find volcanic igneous rocks, maybe you also have the formation of uh, some of the alterations that can be indicated by the presence of clays. And most of the feldspar that is present in these rocks is easily altered into clays, and they give you some sort of appearance in which you have the presence of small pockets of clays that are present on a particular thin section. Well, I think that's all for today, and we have done until the thin section number 24 for today. We'll continue from here. If you guys have any questions related to the rock fragments or feldspar, you guys can ask.